Hello everyone and welcome to the Biamp Sound Masking 101 webinar. My name is Neville Bounds and I'm the Vertical Market Manager in the Building Technology Group of Biamp. So a little bit about me perhaps to begin with. I've been doing this sort of job for quite a long time now, as you can see. I've been working for over 40 years in the broadcast and AV business, both at the integrator level and for manufacturers, both in sales and technical. And yeah, my whole life is about sound really. And I joined Biamp in the middle of last year. And my hobbies outside of work, although they're slightly connected, is podcasting, aviation and post-production. In fact, I do a aviation podcast every Friday evening here from the UK. So thank you very much indeed for joining us. We'll be recording this session and we'll make it available in the next couple of days, and we'll be able to you'll be able to download the slides as well. So the agenda for today then, we're going to look at speech privacy and what sound masking is all about, the key elements which are essential for making it an effective sound masking system. We'll show you some example applications, the advantages of working with us at Biamp, and we'll be taking some questions as well. If you want to ask questions during the presentation, please do, and I will see if I can get to those. If not, I will get to those at the end, if that's okay. So what are the benefits of sound masking? Well, it's quite a big subject really, and the main thing is what we're trying to do is we're trying to protect the speech privacy of people, reduce the distractions of noise in the office, and increase office efficiency if we possibly can. And as buildings have changed over the years, this has become more and more of a challenge. So what is speech privacy? Well, it's defined as the inability of an unintentional listener to understand another person's conversation. The main things people complain about are distractions, which are caused by overheard conversations in the office or larger environments. Also, the level of distraction relates directly to the intelligibility of the overheard conversation. And that speech intelligibility depends on the loudness of the overheard speech compared to the loudness of the background noise. So this is the sort of thing where you hear someone speaking above the level of the ambient sound, and it is a distraction. And of course, when unwanted conversations are intelligible, the brain actually processes the overheard conversation, which leads to the distraction and the loss of privacy. I'm sure we've all been in office environments which have this problem. So the two main categories here with regard to speech privacy are the freedom from distraction and the need for a private conversation. In the section of freedom from distraction, workers have got a need to concentrate without being distracted by the conversations of others. So if you've gone into work to do a specific job, you don't want to be distracted by others. And under the need for private conversation, individuals and organisations have got a need to ensure conversations remain private in order to protect information. So in HR environments or confidential conversations, etc. This is quite an interesting slide, actually. It shows the case for speech privacy. And it's mainly to do with the lack of good acoustic conditions. Very often we find this in large open office situations where sound is transmitted over a large area of the office, and it's a problem because people then are distracted. And then we have the low speech intelligibility, which is high speech privacy between nearby workstations. We need to try and get that if we possibly can. There is a document which is called ISO 3382 Part 3. It's entitled Acoustics, Measurement of Room Acoustic Parameters. You'll be pleased I shan't be going through all of that today, but it's something which is very handy to look at as a reference. So what is sound masking? Well, we define it as the addition of a specifically tailored low-level electronic sound to an environment which is effective when placed at the unintentional listener location to help lower the level of speech intelligibility. And that's a graphic on the right-hand side of the slide, sums it up pretty nicely, actually. It's the way that people can have reduced speech privacy. So how do we deal with this? How do we actually deal with sound masking? Well, there are several ways of looking at this, but this is the easiest one, I would say. So the difference between the background noise level and the signal level from the talker, which is on the left-hand side of the screen, we define as the signal to noise ratio. Now, the larger the signal to noise ratio, the clearer the talker's signal. Now, normally you would want a good signal to noise ratio in public address systems, recording studios, and that kind of thing. But actually, we're trying to do the opposite here. We're trying to take the intelligibility away from the listener. And the way that we achieve that, you'll see in the middle of the slide, is where the background noise level is looked at. And this is where we put a covering sound in order to prevent the background noise level coming through, or the talker level coming through, for example. And this is the way we try to deal with it. And it's dealt with in different situations, but in general terms, the larger the signal to noise ratio, the better the speech intelligibility, versus the smaller signal to noise ratio, which is poor speech intelligibility. There are three main elements of acoustic design. We call them the ABCs. Firstly, is we try to absorb the sound. So in the office environment, using acoustic ceiling tiles and acoustic wall panels is very effective. Otherwise, you can end up with a very reverberant sound. It sounds as though you're in a bathroom, and this makes actually the speech privacy problem even worse. In the building sense, we try to block sound. So the way that we go about that is by using partitions, cubicles, walls, anything like that. And also, if those two things prove not to be fully successful, then we can apply background sound and sound masking to the environment. And this is a very effective way of going about it. So it's A plus B plus C, all those things together give us the speech privacy. Now, in order to make these effective, you need four key elements, really. The uniformity, the zoning of the system, the spectrum that we're going to operate within, and also the level. All of those things are really important. Otherwise, you don't get the best possible effect. So let's get the first part of this, the zoning. On the slide here, we've got several offices around the outside. We've got a conference room. We've got 4 private offices at the top. We've got a reception area at the bottom, and then we've got a main open office area. You can put these into several different zones. So we're going to use the open office area as zone 1, the private offices as zone 2, and the reception area is zone 3. And we do this because we have different situations in different areas there. We've got different numbers of people, for example. So we're able to use different levels of sound masking in different zones. The uniformity part of it is really important in my view. If you've got a system which is not uniform, you end up with a problem where you're walking around the office and you can hear the sound masking at different levels, and this is not desirable at all. You have to have a situation where you've got the most uniform sound possible, and this is done by properly tuning the system, which I'll come on to later in the presentation. But I cannot emphasize enough that tuning and commissioning of the system properly is absolutely vital. To give you an idea of those zone areas that we've been showing there, so we've shown the private offices, the corridor spaces, and then the open offices, and these vary from one area to another. So we're showing you that the range here of sound masking level targets. So as you can see in the private office range, we're in the 38 to 42 dBA. In the corridor, it's 41 to 45 dBA, and open offices, it's 44 to 48 dBA. These are really important because it means that the type of sound masking is used appropriately in the different areas that are being covered. Now, sound masking spectrum is very important as well. The frequency range that we're dealing with is in the 200 Hertz to 5 kilohertz range, and this is typically the normal range of human speech, for example. And that's a very important thing, because there's no point in doing sound masking outside of that. And as you'll see shortly, we offer several different solutions according to what you need to do. But that graph on the left-hand side of the screen is a very good example of the frequency range along the bottom and the amplitude, the decibel amplitude that we use on the vertical axis. And where the sound masking spectrum is that blue band across from the left to the right-hand side. To go into a bit more specific detail about it, there are various parameters that we try to look for. With sound masking, it's really important that you've tuned and commissioned the system properly, as I mentioned. And here is a set of figures that we use for US or EU figures or UK figures. And as you can see, there's some comparisons between the three of them. But when we come to tune the system, these are the levels that we try to achieve. And we also need to take a close look at the structure of the building and the makeup of the walls, the floors, ceiling heights. Again, I'll come on to that later on, because that's quite a big subject. And the key elements that we need to look at are the upper and lower areas, with a target area somewhere in the middle. So again, in that speech privacy area, the areas we're trying to look at, up to a maximum of 5 kilohertz at 18.4 dB. But the main area, as you can see, is right in the middle there, somewhere between 400 hertz and just over 1 kilohertz, for example. Those are the key areas that we need to look at. There's no point in going very much below or very much above that, but the sound masking target has a very specific range, which we can advise on as well. We also need to tune the system, as I mentioned, and you can't just do this by your ear. It really does need some proper high quality equipment in which to do that, which we have, and a lot of our sound masking installers use as well. This is absolutely critical for tuning the system properly, so that it works in every situation, and so that it's not possible for it to be detected or become obtrusive, for example. So I'll come back to that a bit later on, but this is the sort of equipment that we would use to tune the system and to analyze the audio. So we've got several methods of approach for sound masking, depending on the area that we're talking about. We've got the direct field system, we've got the plenum system, we've got an underfloor system, and we've got eavesdropping systems. These prevent eavesdropping into rooms. Let's just go through those one at a time. The direct field system uses emitters, which are mounted in the ceiling space, in ceiling tiles usually. And you can see here that we've got an area where there are 4 zones being used within a space. And we've got another area here, which is the in plenum solution. So this is the indirect system that we use. And the way this works is that the emitters, the speakers, actually placed into the plenum area and bounced off of the main structure of the ceiling back into the room. We also have an open structure system where you've got that from a ceiling point of view, and that again uses an indirect system, just like we did in the previous plenum system. Also, we can do underfloor systems as well. Now, these take a little bit more working out because they're slightly more sophisticated, but we do need to know the brand of raised access flooring, the open locations, and we also must know the plenum height in order to do this system properly as well. But this is definitely possible, and we've deployed many of these around the world. The eavesdropping systems that I mentioned are very useful as well, especially when you want to avoid people listening into conversations that are going on within inside a room. And these are often used in military installations, government installations, or very sensitive areas. Just to give you an idea of the comparison of the accuracy that we can measure these to, the direct field system is by far the best possible system if you can possibly achieve this. This is because we have a direct projection of the emitters from the ceiling. The network plenum system, we're able to achieve plus or minus 1.5 dB. The 70 and 100 volt line plenum system is between plus and minus 3 dB, and the underfloor system is between plus or minus 1.5 dB. We don't recommend the 100 or 70 volt direct field system because of potential comb filtering issues. I'll come on to explain what that is in just a second so you can see what I mean. But as you can see, our preference, as always, if you can possibly achieve it, is a direct field from a false ceiling. But if that's not possible, then we do have many other versions as well. So let's have a look at the direct field sound masking systems. First of all, these are the products that we offer, and we'll go through them one at a time. Well, the QT Pro system was really developed by acousticians. We're looking for a better way to provide a consistent and uniform sound masking solution. I mentioned right at the beginning how important that uniformity is in the office environment. We've got a patented direct field approach, which utilizes very small sound emitters, which you use in place of above ceiling speakers. So again, you can see that these are actually mounted into the ceiling tile area. Rather than using a single channel, we actually use a multi-channel design, which alleviates acoustic interference, and it has 4 separate sound masking generators. And this means that you don't have any of the problems of odd sounding situations when you're moving around. It sounds very natural indeed. The reason that we like the direct field where we can is for the speaker uniformity, the ability to have very, very similar or matching sounds throughout the whole office environment. This is why we use the QT Pro system with the direct field. This enables us to get very good coverage and very accurate coverage, as you will have seen earlier, where we can have plus or minus 1 dB accuracy across the whole space. And what we try and do as well is minimize the sound inconsistencies within sound masking due to different acoustic and ceiling variations. So this actually levels and evens it out rather well. In fact, it's a very good system, and especially when it's tuned to the correct level as well. It works very well indeed. The sort of installation that we would use here in this example is the QT300 controller, which is on the left-hand side. And remember that only the air between the listener and the emitter provides consistent result. That's a really important part to remember here. And this is why we don't use just a single channel. So if we had all the emitters just set to one channel, we'd have a situation where we end up with this comb filtering problem, which is very well demonstrated here. When you're moving around the space, it sounds very odd indeed, and in itself would be a distraction. So we try to minimize all of that kind of thing by using separate channels which put out different frequencies. So again, in the case of our QT300, we connect it to the 4 emitters from channel A, channel B, channel C, and channel D. And this eliminates the comb filtering problem and results in really good uniformity across the space. So what are the core components? What are the products that we use here? Well, on the processing side, we have 3 models that we offer: the QT100, QT300, and QT600. They are connected from the processor by Cat5 cabling. Actually, it can be as small as Cat3 cabling if you wish, but Cat5 is the more popular, and therefore that's what we tend to use most of. We have 2 types of emitters. We have the passive emitters up on the top there, and the active sound masking emitters on the bottom of the stack there. And these are very small in terms of the way they're presented. In fact, they look rather like small loudspeakers, which is what they are. We call them emitters, but that's exactly what they do, in fact. So in a system, you have the controller itself, which in this case is the QT300. That is connected via the Cat5 cables to the emitters directly, which are mounted within the ceiling space. You then have a home run cable which comes all the way back. So the home run cable actually is from the processor to the first emitter. There are then interconnect cables between the emitters. So these are literally loop through on Cat5 cables. And this is very useful because if you're doing an installation where there's already an electrical contractor or a cabling contractor on the site, they can actually put all this in for you according to your drawings. So there's no special cabling required here at all. And then you simply connect the sound masking emitters to the ends of the Cat5 cables that you've terminated. So which kind of emitter is best to choose? Well, this is the passive emitter, or the standard emitter as we call it, and we use this only for sound masking applications. It can't be used for anything else. It can be powered directly from the control processor, reproduces up to 60 dBA of sound masking, and again it's in that sweet spot of frequency response from 200 Hertz to 5 kilohertz for the sound masking. On the back of it you can attenuate it in 3 steps using -3 dB, -6 dB or -9 dB according to your installation and what sort of level of sound masking you required. As I mentioned before, it daisy chains using category type cables. So the standard connectivity for a processor is as here. So you go from the control processor itself into the first emitter, and then literally, as I mentioned earlier, you can daisy chain between the two emitters, and then you just keep going with interconnect cables of 16 feet, 25 feet, or 30 feet, which we can supply. The usual thing though is people use their own cabling and terminate it as well. The maximum cable length is 1,000 feet cable distance in total, or 60 QT adjustable emitters per cable run. We also offer the active emitter. This is used when you want to use it for sound masking, paging, and music applications. Much higher quality product in terms of the frequency response available. In the music sense, there's 74 dBA of sound level available, and it reproduces up to 60 dBA of sound masking. It's also got its own internal audio amplifier, and it has an extended frequency range for its own sound masking of 125 Hertz to 6.3 kilohertz. In the music sense, it's 105 Hertz to 16 kilohertz, which is actually very high quality for voice and music, and it's a very useful substitute rather than having to put in PA speakers separately. Again, these are daisy chained from one to the other using category cables, and on the rear you'll see those dip switches for the attenuation steps of, in this case, 1.5 dB, 3 dB and 4.5 dB. The way you hook it all up is explained here. We use the PIAE power injector and the PSAE3 power supply. Now the power injector supports up to 50 QT active emitters, so we use them up to a maximum of 25 per port. It plugs in line with the QT control processors and the QT active emitters. You can use 2 QT active emitters powered signal cables output ports, and you'll see on the right hand side the schematic where all the connectivity is. Now the power supply itself takes a standard IEC connector coming into it, which is a switch mode power supply suitable for 120 volts or 240 volt operation, and that has a maximum of 150 QT active emitters. There are 3 output ports for power connections to the power injectors. An example of the schematic of that is as follows in this slide here. We come out of the QT300 processor into the power injector, And then there's a separate port on the power injector which is connected to the power supply, as you'll see on the left hand side. And from the power injector, just like we do with the passive emitters, we go from one unit to the other in a daisy chain sense, as before. On this occasion, we can have 125 meters of cable distance or 25 active emitters per cable run. And on the second leg of the power injector, we can have other areas as well, which are then powered from the power injector and then back from the power supply too. Now, in order to mount the emitters, we offer a whole range of different mounting accessories, from the universal bracket through to the beam bracket. We have the QT adjustable caps for the passive emitters, which we are able to spray with a RAL color should you so require. We have adjustable plenum back can for the areas which have a large plenum area. We've got a pendant mount, a drywall mount, and a pre-construction drywall bracket kit as well. If you have any situation which is unusual or difficult, or you're finding difficulty choosing a solution, please do let us know. We've mounted our solutions into all kinds of situations around the world, so we've probably done it before, is what I'm saying. But if you have got a situation where you can't come up with an immediate solution, do let us know and our design team can advise you. So with those control processors then, they're called QT 100, 300 and 600, as I mentioned, because they deal with a single zone, 3 zones or 6 zones. And those number of zones can be determined by the differing emitter mounting heights with a 150mm offset, different types of spaces that require separate sound levels of masking, and the need for audio sources in specific areas, especially if we wanted to use the PA or music application, for example. The QT 100 control processor is a single zone solution, which has a separate masking level, separate audio level, pre-configured sound masking spectrum, and a hole saw and power supply included. It's also a wall-mounted solution. The hole saw is very useful. I use that extensively, and it means that it's another tool that you haven't got to worry about for when you're cutting out holes for the emitters. You can have 4 sound masking generators per zone with 2 cable runs, which each support 60 adjustable emitters or 1,000 feet. There is no network connectivity to this item. It is merely a standalone item. It also has an audio input, which can be used for door chime, for example, and it's also got an I/O contact closure, which can be used for turning the masking off should you require it. So that's a dry contact closure in order to do that. Now, the QT 100, as I say, is single zone only, and it is only compatible with the standard passive emitters, 120 of them. You cannot use it with the QT active emitters. You have to use at least a QT 300 controller in order to do that. However, this will take you up to about 12,000 square feet on a single zone. So it's actually a very versatile unit if it's just a single zone that you require. It's also possible with the QT 100 to have a fire control panel, so you can have an emergency contact coming in on that contact closure, or a door chime as well via an audio input. And as you can see, this then connects to the rest of the system in an open office environment up to a maximum of 48 dBA. We've also got a secondary zone. Although it's a single zone as such, there's a second run that can be used if you have a corridor, for example. So actually the QT 100 on its own can do quite a lot, although it's a single zone, but the corridor is at 45 dBA as opposed to the open office, which is at 48 dBA. Again, we've got a maximum of 1,000 feet run cable distance or 60 QT adjustable emitters per cable run. The QT300 control processor offers us 3 zones. And again, we've got separate masking level per zone and separate audio level per zone. This can be a pre-configured sound masking spectrum, which you can adjust. But this time it also includes time of day scheduling and audio and sound masking levels, as well as auto ramping of sound masking. So for example, if you're installing a brand new system, rather than just switching it on, you might want to ramp it up over a week or a couple of weeks, for example, in order for the staff to get used to the sound. Again, we include the whole saw and power supply. We also have the rack mount kit available as well, but it is wall mounted as standard, but there is an optional rack mount kit available too. This time we've got 4 sound masking generators per zone with 2 cable runs which support 60 adjustable or 50 of the active emitters. We have got network connectivity on this one, which is via Ethernet. It's also got its own built-in web server as well. And this time we've got 2 audio inputs, which are zone adjustable, and 2 contact closures for masking to be switched off, or for one of the audio channels to be switched off as well. This unit is compatible with the standard emitters or with the active emitters. Again, if you remember, the standard emitters are the ones which are the normal ones, if you like, but can't be used for PA or for paging or music. But the active emitters are the ones that can be. So the total capacity of the passive ones is 360, or you can use the active, and the maximum capacity there is 300, and that can go up to about 36,000 square feet across 3 zones. The big brother is the QT600, very similar specification to the 300, except that you can control up to 6 zones with this. So this is for the larger spaces, or if you need to have substantially different sound levels in different zones. Just like the QT300, we have 4 sound masking generators per zone, 2 cable runs which support either 60 adjustable or 50 active emitters. We've got the built-in Ethernet and web server, 2 audio inputs which are zone adjustable, and again the 2 contact closures for fire alarm input. We can do larger areas here, right up to 72,000 square feet or 6 zones, and this time we can use 720 of the passive emitters or 600 of the active emitters. A typical layout, for example, of a QT300 might be something like this here, where we've got a maximum cable distance of 330 meters. We've got them across 2 runs, again, where we loop from one emitter to the other. In the active cabling schematic, where we have the power injector and power supply on the left-hand side, you'll see some distances there as well, of 180 meters maximum between the control processor and the injector, and the power supply can be 120 meters maximum from the injector. Normally, you would put the QT300 in an IT or audiovisual systems rack, something like that. And the diagram on the right-hand side shows you how many emitters you can have on each output, as well as the types of signal cable that you use at the bottom of the picture there. When you're using the QT300 or 600 with the QT emitters, you can start getting quite sophisticated in what you can do here by having a large number of emitters over separate runs in separate zones, for example, in different environments, so open office, private offices, in the lobby or corridor environment. And again, all these are fully adjustable and interchangeable according to what you want to do. We'll come on to the design of this later on, because this is a really important part of the service that we offer. And again, on the top left-hand side, you'll see the types of cable that we need in order to do this. So remember, the QT300 we can use for paging and music just as in the same way as we can for the QT600. So the cabling I've covered slightly already by saying that we just use standard category UTP cable, which can be anything from Cat3 upwards. It has to be a straight through cable. It cannot be a crossed cable. So it's really important that it's a regular straight through cable, and you need all 8 conductors connected as well. When you're installing your systems, it doesn't matter what it is, whether it's audio, visual, video, lighting, sound, cable integrity is really important. So it's always worth making sure that you've got a cable tester for this kind of thing if you're installing your own cables, to make sure you've got all 8 conductors connected. With the QT Pro range, we also offer the control software where we can do scheduling, we can change the masking EQ, we can change the input EQ, and there's a special administration page as well. So this is a fully standalone system which can be used to schedule the level of sound masking depending on when you want it during the day. And you'll see in the middle, as I mentioned earlier, you can actually ramp the system up and down as well according to what you want to do. So normally we want to keep it at a constant level, and the way we do that is ramp it up over a period of time. And that pop-up menu which says 60 minutes can go up to, I think, 14 days, I believe. So there's plenty of possibilities of changing that. Now, as a completely separate system but based on the QT system, we offer various standalone systems which can be used for medical applications or for private office spaces and conference rooms. This is a system in a box. Actually, we have 2 systems, the HCE and the CRE. So one's for the healthcare and one is the conference room, and they are identical, but they just look different. So the healthcare one is got a silver plate front panel, and the conference room one has got a black front panel. Now, within this pack, you get 8 emitters included straight out of the box, with 2 levels of masking, 2 privacy signs, so you can actually see that there is speech privacy protection going on. All the cables are included, as well as the standard brackets and housings which can be utilized too. You can add additional emitters to this as well, the standard ones, or you can also interface this with other control systems as well for automation processes. So AMX, Crestron, Extron, Kramer, all of them, and anything else that you want to do. We have all the protocol in order to control this system as well. So this is designed as a complete standard unit. So it's an example of the Contra conference room version where we've got one exposed wall with 2 rows of emitters. So you can see here we've got the privacy sign on, which alerts people to the outside, and the on sign confirms the privacy for the people inside as well. And then we wall mount the QT conference room edition, the CRE. This is not something which you would put in a rack equipment, or I mean you could do, but it's really designed to be on show, which is why it looks slightly nicer than the other units, which are designed to be rack mounted. Now, here is a system which we also offer, which is a completely different approach to the QT Pro system. It's called Dynasound Pro, and it's all about indirect field masking. The way we go about this is entirely different. This is a constant voltage sound masking system which provides signals to listeners by using an indirect system, by upward firing the loudspeakers into the plenum or the open structure environments. And we use this when consistent ceiling types and architecture exist as well. It has very large sound masking and paging zones because of the amount of equipment that can be used in it. And it uses many loudspeakers on a single channel as well. Now, the network system also provides sound masking in the same way, but we can also be used in the underfloor and direct field environments as well. This provides higher sound masking generator and amplifier counts with fewer speakers per channel, and offers better controllability, so you can have much more granular performance in the paging zones as well. And let's look at why this is important. Single channel sound masking systems consisting of large loudspeaker groups offer little controllability, unfortunately, to overcome things such as obstructions in the plenum space and openings in the ceilings and variations in ceiling materials. So what we do is we have, again, multiple channels, just in the same way that we did with the QT Pro system. So we've got the ability to address individual loudspeakers instead of whole large groups. And this makes a big difference in this sort of coverage that we're able to offer. Now, again, I mentioned earlier that tuning is vitally important for all systems, but particularly so for the Dynasound system, as we're using the plenum area to actually use an indirect system. So we would use, again, a special set of products to do this with, and our integrator friends use this as well. And there is actually a standard tuning procedure called the ASTM 1573. And this is used at 4 feet above the floor at seated listener height. So again, so that you make sure that you get even coverage. And it's always worth spending as much time as you can tuning the system properly, because the installation is very straightforward, but the key to it is proper tuning of the system. No question about that. And the tuning actually needs to compensate for the acoustic loss that you're going to get within the ceiling and architecture as well. So this works very similar to the network system here, where we use the DS8000 amplifier. And this is cabled along to the upward facing speakers, just as we had before. And when it comes to the plenum area, you'll see that there is some depth there, but there also is a very large ceiling height as well. So this is important when we come to do the design of the system. We can also manage all this software just in the same way as we can with the QT system. We can do masking level adjustment on a system-wide basis, or a zone basis, or individual speaker control. And that device list may be by IP address, location ID, or by zone. So it's very flexible in terms of what you want to do. We have availability for input processing control, the output matrix mixer, the internal generators, and the device monitoring and configuration. These are all very important when it comes to setting up the system. So the DS8000 controller has 8 audio amplifiers built in, which are then sent out via the Phoenix connectors, which you can see on the side of the unit. It's got 4 onboard sound masking generators with onboard EQ and a mixer, and we've got individual control for each of the loudspeakers. We've got 4 or 8 ohm voice coil output, and it is actually UL 2043 plenum rated. So again, this is a product which is going to go into the plenum area. We've got 8 audio channel input channels via the network, and we've got PoE Ethernet power ability as well, and the unit is IP addressable. So in the plenum network system, we've got 4 different sound masking generators, and these can be assigned to any of the 8 speakers as you require. 4 different equalizers are available to overcome the tonal anomalies, which is 1 per generator, and the loudspeakers can be adjusted by the software with separate level control. Again, you need to make sure that you've made allowance for variation in ceiling and architecture as well. So it's very important to make sure that you know what you're dealing with. The DS1356 speakers, again, we use these in the plenum and the open ceiling applications, which are available in black or white, and also available as a 70-volt option as well. The underfloor solution, we use the DS1398 speakers, and these can be used where you've got limited plenum space and also in open ceiling applications. We've also can make these available as a 70-volt line option as well. The DS1320, these are the QT Pro direct field emitter. They're modified specifically for the DS8000 system. And these are used in the ceiling areas where music or public address is required. Again, we make them available in black and white, but they must be used with their own controller and cannot be shared with other different speaker types. For the DS2450 speakers, these are used for mounting on solid surfaces such as windows, doors, or HVAC. And again, they must be used on their own controller and can't be shared with other speaker types. Other accessories that we offer for the system is the DS3008. This is mainly used in the 70-volt systems, but can also be used with a network system too. It has a matrix with 4 sound masking generators built in and 8 analog line level audio inputs. There are 8 line level audio outputs for the 70-volt line systems and Cobranet connections for the network systems. We also do a DSTS10 PoE, which is a touchscreen PC controller for the network system. That should say rack mount kit included, not rack mount kite included. I do apologize. So to give you an idea of the typical applications that you might have for acoustics and privacy, we look for a target background noise level. That's really important. These slides will be available later on, and you can look through all these individually, so I won't actually read them all out. But in general terms, the area that we're looking is a background noise should be raised to about NR38 in order to increase the speech privacy. We're trying to bring up the noise level deliberately in order to use the sound masking systems properly. In the solution there, we use a direct field system. We've got 2 zones, and the areas are adjacent, and they are required. They've got specific levels that are required in each area. So in order to do this accurately, we must make sure we use the QT Pro system, because the plenum systems will not have the same level of control. In the meeting room environment, what we're trying to do here is we're trying to mask the room itself, which we have to do outside. So outside the room, meetings from the speech can be heard. Speech from the meetings can be heard, which is often a confidential topic. So this has to be done outside in the corridor area. And again, inside the room, there can be distractions coming in from the outside with people walking around. So in this situation, we'd use 2 zones, zone 1, which would be inside the room, and zone 2, which would be outside the room in the corridor area, to reduce the intelligibility from the speech. The open office environment is always a challenge. This is because these days we are seeing more and more open office spaces, fewer and fewer small offices themselves within that space, and also fewer partitions as well. So there's a lot of distraction that can occur here. It's interesting to note that it's said that employees are interrupted by speech once every 11 minutes and waste an average of 21.5 minutes per day due to conversational distractions. And there's also a table of the UK findings there as well. So the solution here in the open office environment is we try and change the radius of distraction. If you look on the bottom right-hand side, or just to the right of the main diagram, you'll see what happens when we have the radius of distraction without the sound masking. With the sound masking put in, we have a much reduced radius of distraction, which is far more effective. In the closed office environment, we take a slightly different approach. We have a single zone of sound masking, but actually we can solve the problem by using direct field speakers here as well. Again, it's important to provide us with as much information as you can with regard to how your room is constructed, the ceiling heights. So a general floor plan is normally good enough for us to work with. And the advantages of working with us are, well, as follows really. We try very hard to make sure that we interpret your designs properly and your wishes in order to make sure that the system is effective. If you can make sure that you give us as much information about your system or your problem as you can, we have an excellent team of designers at Cambridge and also around the world, which enable you to bring forward your problems, and we will provide solutions to you. We work through a series of systems integrators throughout the world who can help you install these systems or can advise accordingly. So anything that you need at all, we're able to help with on the sound masking side of things. We've been doing it for a very long time, And I'd like to say that we're about the best in the business when it comes to this kind of work. We've got a lot of many years of experience of it. If you have any questions that you would like to ask me, then could you send them to my email address below there, neville.bounds@biamp.com, and I'd be absolutely delighted to answer them individually. But thank you very much indeed for joining me today. And as I say, anything you need to ask me, be very happy to assist. Thanks ever so much.